Hello, everyone. I'm Dante from the University Carlos III of Madrid. I'm from the Arcos Research Group, and I will talk to you about a system that we call DynoStore that we are developing in conjunction with Globus Compute and ProxyStore. So, some context, we have many storage silos available. Each of them have a different storage capacity, and they are managed by different organizations. We know that data is produced anytime and anywhere from edge devices, and that is from edge devices onto individuals and things like that. And this data is used in different data science problems or e-science problems. And some of them require the cooperation among different organizations. Data is stored in these systems. This system can be administered using different file systems like Ceph, Lustre, or Hadoop, and the access to distribute storage systems is sometimes complex, and they implement different protocols and mechanisms to access and store data. So the idea is to create a system composed of storage systems. The idea is to have a interface that can be deployed through these storage systems to couple them into a single system that can be used for the sharing and storage of data. So we call this system DynoStore, and it's based on abstractions called data containers. A data containers basically it's an abstraction that is put as an interface over existing storage systems. They have input-output interface to allow the access of remote users. They have access control layers and caching to move data through in memory and the file system. These data containers can be connected to create different data channels which could be asynchronous or synchronous. In our approach right now, we have a centralized metadata server that can be distributed through different instances that orchestrates the movement of through the data through data containers. Yeah. So this is how it looks. The global architecture. We have an access layer where different clients can connect to access the rest of the services. Then we have the centralized metadata control that manage the allocation and location of data through the different storage locations, which are masked through different data containers. So we have data containers deployed on the storage systems, and under these data containers are the native storage systems to manage the data. We also implement load balancing to distribute the data through them, and also we implement different data resilience policies to add fault tolerant mechanisms to support failures or unavailabilities of some storage locations. Yeah. On the top, we use a ProxyStore to connect serverless applications to the rest of the storage architecture. Basically, ProxyStore manage remote Python objects in the serverless applications, manage the reference to the remote objects in these serverless applications, which are developed using the Globus Compute. So here there is an application that was developed with this system. This system, basically, we have a storage layer that is managed by DynoStore. We have different organizations that are producing data and sharing data using DynoStore, and we have different applications to process data. So the infrastructure available by each organization is managed using Globus Compute endpoints. And these boxes are basically Globus Compute functions to process, in this case, medical data. We are processing electrocardiogram data and electrocardiogram data. So the data is processed through different applications for the pre-processing and for some processing using machine learning algorithms. And the results are stored using DynoStore and shared through the different organizations using DynoStore. So this is our results from this application. Basically, we create an autonomous system that we automatize the deployment and execution of functions using Globus Compute, and we automatize the movement of data using DynoStore. So we create this flow where the data is processed through where tomographies are processed through a machine learning algorithm to identify tumors in the images. We trained different machine learning models, 2 versions of ResNet and 2 versions of YOLO, and we got different precision values, and the model trained, we put it in a data flow for the processing of these tomographies.